Hi, everyone. I'm Adam Marcus. I'm an associate professor of architecture at California College of the Arts in San Francisco. I have the distinct opportunity and pleasure of introducing the recipients of the 2016 ACADIA Digital Practice Award of Excellence. This award recognizes creative design work through that advances the discipline of architecture through development and integration of digital technologies. Previous recipients of this award include, in recent years, Akim Menges, Jenny Sabin, Kieran Timberlake, Cecil Balmond, Gary Technologies, and Gramazio Kohler. Today, I'm pleased to introduce this year's recipients, Ronald Rael and Virginia San Fratello. Ron and Virginia are no strangers to this community. They have presented and exhibited at numerous previous ACADIA conferences, and I'm sure their work is no doubt very familiar to everyone in this room. Together, Virginia and Ron direct Rael San Fratello, an award-winning creative practice, which, among many other honors, was named an Emerging Voice by the Architectural League of New York in 2014. They are both, excuse me, deeply committed and recognized educators. Virginia at San Jose State University, where she directs the interior design program, and Ron at UC Berkeley, where he holds a joint appointment in the architecture and art practice departments and directs the Print Farm Laboratory. Ron and Virginia have received much recognition in recent years for their work in the realm of additive manufacturing and 3D printing. Together, they founded and direct Emerging Objects, which is a startup company that they describe as an independent, creatively driven 3D printing make tank, specializing in innovations in 3D printing architecture, building components, environments, and products. Emerging Objects has fabricated and constructed a number of increasingly large 3D printed structures using a variety of experimental materials, including ceramics, concrete, chocolate, tea, wood, and salt. The awards committee specifically cited this work in multi-scalar digital fabrication, 3D printing, and material research as particularly remarkable and deserving of this recognition in digital practice. I would add that also what distinguishes Virginia and Ron's work is its melding of material craft, really kind of expert sensibility of material performance and how things are made, with a really projective and even visionary notion of how mastery of these practices can point to larger transformation in industry at a much larger scale. So as a way to kind of further introduce you to the work of Virginia and Ron, we'd like to show a short film produced by Cynthia Davidson, which speaks to the links between their practice, research, and teaching. And then Ron and Virginia will come up and say a few words after this. So let me...
We started 3D printing 6 or 7 years ago.
We're testing how do you make a very large object with a very small 3D printer. And so we printed these blocks and we asked our son to build a wall, and he took the bricks and he built this 3D printed wall himself. And we said, okay, we're on to something. We don't know if 3D printing will be a viable process for the building industry, but we believe so. And this is what we're researching. This is about speculation and investigation. I'm Ronald Rael. I'm an associate professor of architecture here at the University of California, Berkeley.
I'm Virginia San Fratello, an artist, an educator, and an architect.
We have a studio called Rael San Fratello.
And we're partners in Emerging Objects.
Most of the objects that are 3D printed that people know about are made out of plastic. We wanted to make things out of different kinds of materials that had more integrity. That's really great material. In some way, all materials come from a powder source, whether it's powder like sand that turns into glass or iron ore that turns into steel. So we were interested in those kinds of materials and how they could be used in a 3D printer. This is salt that's been harvested from the San Francisco Bay. We're going to make a 3D printable material.
3D printing with salt is incredibly inexpensive. It only takes sun and wind to make this material.
There's 330 tiles that have been printed.
It goes back to this idea of using literally the ground underneath your feet and thinking about how that material can become the architecture.
What one could do with this material and what its possibilities are.
These materials that we're using, many of them, are already in the construction industry waste stream. So we've developed a formula for 3D printing with recycled rubber tires. Tires are one of the world's biggest material waste problems. We 3D print with cement, with wood.
Coffee, tea, sugar, bone. The objects that you see on the table are all about a controlled failure. It all started by wanting to 3D print clay. We were really learning how the printer works. How does clay behave? We've traveled all over the world looking at buildings made out of earth. In traditional cultures, frugality drives design often. And frugality can make something enormously elegant because something has to be useful and it has to be beautiful and it has to be well made at the same time.
The diamond mesh pattern in here, like this. We're currently working towards designing and 3D printing a house.
We're not so excited about the idea that a single giant machine can 3D print a house out of a single material.
Matthias, your dinosaur is going to be done in a little while.
We like our floors maybe to be a different material from our walls. We like some materials soft and some materials hard. And we'll just keep this flush.
Currently we have 3D printed clay tiles that make up the exterior cladding.
We're allowing the machine and gravity and other forces to take effect so that each part ultimately ends up being different. I can totally imagine it being the whole skin of a building. Yeah, can't you?
And we want to 3D print everything in the house.
That is 3D printed. That is a 3D printed lamp. That's 3D printed.
If we could 3D print the cutlery and the dishes as well, it would be a total work of art. I think a lot of times we feel like we have to justify beauty.
Comments are always, is it functional or is it just beautiful? But why is beauty never considered a function?
We look at our own work and we say, okay, you know it's not right until everyone around you can look at it and say, that's beautiful.
If beauty has a function, it makes us happy. We would see something and say, what's the function of that pattern? It just makes you happy.
We're inspired by the Berkeley Botanical Gardens.
Completely twisted and folded up on itself.
The plants collected there, their forms, curvaceous surfaces are looking along the perimeter.
Like hair.
Plants are good at controlling and funneling water, shaping themselves to point towards the sun. So they do some things that we would like to do in our designs.
What if a brick can also be a planter and hold vegetation?
Our cool bricks are designed to take advantage of passive cooling technology.
Maybe here there's a new kind of structural shell that you can occupy. I think one of my focuses when I teach students is that I'd like them to know that design isn't shopping. Can't wait to see it all come together. They're in control of the making process.
And now we're trying this woven one. My name is Rebecca Russino. I'm a grad student here. I'm looking at milkweed as a building material. Actually, I was thinking maybe we could use that G-code. It's good at acoustic dampening, thermal insulation, absorbing oil.
They can draw inspiration from the world around them, from art and from theory, and they can be innovative. Here's the old printed hem.
So how can we make something new to be implemented in a new architecture for the 21st century?
How much function can you pack into design? How many layers of possibility? I think that's what we're after.
So please join me in congratulating Ron Rael and Virginia San Fratello for receiving the 2016 Digital Practice Award of Excellence.
Wow, thank you so much, Adam. Thank you. Good afternoon. So we feel so fortunate to be here in a room filled with so many friends. Some are colleagues whom we work with or whom we have close academic and professional associations with. There are also many former students here who've been in our courses or who have interned in our studio and have gone on to their own successful and interesting practices. And some of you are even our classmates in school, and you're now leaders in the field. And there are also so many of you in the audience who we have not yet met, whose work, like those of our friends, colleagues, students, and collaborators, we have admired immensely over the years. We were very surprised to learn that we received this award, so we are very grateful and honored to be this year's recipients. Ron and I met in 1995 at Columbia University, where the concept of the paperless studio had just begun in the year before. And Evan Douglas, who was in fact a past recipient of the Digital Practice Award, was our first professor there. And Evan has been enormously influential in the way that we continue to explore matter, culture, and research in our practice today.
Access to technology and funding has always been a critical topic raised at this conference, as well as many others that we've attended in the past. Computers, printers, robots, and time are all enormously expensive. But our work came from both our desires and capabilities in digital practice, but also our lack of resources. Inventing materials for 3D printing was our way of gaining access to a technology that was very much out of reach for us. Doing the most with the least has allowed us to work with very lean budgets, and all of our work until recently was produced with very limited resources. When we realized that if we rolled up our sleeves and took control of material development, a technology we found to be inaccessible because of the cost of materials and machines, 3D printing could now be within our grasp. It currently costs about $4,000 to purchase 100 pounds of proprietary powder and binder from 3D printer material suppliers. We were able to reduce those costs so that 100 pounds now costs us only $40, which has opened up so many possibilities for us of how to conceive additive manufacturing as a technology that might contribute to the making of architecture with a rich material palette. Our own personal backgrounds have also shaped the way we work. We both come from very humble and rural environments. Virginia grew up on farms in Alabama and North Carolina, and me on a sheep and cattle ranch in Alpine, Colorado. Our approaches to materials for 3D printing that are recycled come from waste streams or sustainable sources, or that are ubiquitously available, like salt and clay and sawdust, recycled tires, emerged from the direct experiences with the material world of our youth. Our work has been the manifestation of desires to explore additive manufacturing through material provenance. We want to know where materials come from and how they're mediated through technology and where they're going, and this has become the central focus of our work. We believe that all architecture emerges from geological and biological sources, and it's our task as architects to transform it into future understandings of anthropology and archaeology.
So we call our laboratory the print farm. It's where we grow and harvest architectural components from the seeds of material ecologies that have important histories and context. Our philosophy thus far is that not one single machine or one single material will produce the 3D printed architecture of the near future, but a farm of smaller printers working together to produce manageable and reconfigurable parts that can be elegantly assembled and disassembled of very different kinds of materials that are translucent and opaque, soft and hard, familiar and unfamiliar, are all essential parts of our own aspirations for architecture. So, what's next for us? Well, we're currently working on a 3D printed cabin. It's a fully functional house that uses a range of 3D printed materials, ceramic, bioplastic, cement, sawdust, and most recently recycled grape skins from wineries in Sonoma. We're exploring multi-material printing, where in one print we can move seamlessly from geological to biological material sources. We're moving in the direction of mobile 3D printing. So we're going to take our printers outside of the print farm and into the field to reach larger communities. And finally, large-scale 3D printing with local soils. Our first endeavor into hardware design, which we are authoring, that makes more specific the generalist nature of 3D printing. What currently is conceived as a technology that can produce lots of things, to a hardware whose sole duty will be the production of earth walls.
So we want to thank all of you here today, the ACADIA Awards Committee, as well as the organizers and members of ACADIA for this award. We'd also like to thank our son Matthias, who's here today because he helps us excavate parts and vacuum and offers insightful and often very frank advice and critique. To all of you, we thank you for the inspiration, for the conversations, and for your allegiance to the advancement of architecture that this organization and conference embodies as it continually advances the profession. Thank you very much.